The Arctic Ocean is ice covered most of the year, although that is starting to change as temperatures rise. The Arctic Ocean plays a crucial role in our planet's climate system, since when the ocean is covered by ice, it absorbs less heat from the sun. Underneath the sea ice is not just plain water. In fact, the water is salty. Let's imagine two glasses of water, with different amounts of salt in each one of them. The saltier one will have a lower freezing point temperature. This means that as we cool both of them, the glass with higher salinity can remain liquid at temperatures where fresher water has frozen. Pretty cool, right? This happens also in the Arctic Ocean. The salinity varies across the Arctic Ocean, and it has a big impact in the temperature at which the sea will freeze. Within the Arctic, there's also the Arctic marginalized zone, or the region of transition between the open ocean into the sea ice. Within this region, we see big difference in salinity and temperature that in fact move all the time around. When this happens, they create these cool features that we call eddies. So we wonder if eddies play a role on how sea ice grows as the temperature decreases. To figure this out, we turn our attention to computer simulations. What we found was pretty wild. When these eddies are around, they mix up the temperature and salinity at the surface. These changes in temperature and salinity create heat fluxes and salt fluxes at the ocean interface that leave a mark in the sea ice thickness. It's like the eddies are painting the sea ice through the heat and salt. The stronger the eddies, the more artistic they get, creating more variability in the sea ice thickness. Now let's break this down a bit. Picture the ocean as a shoebox with 3 different levels of salinities. We've also got our eddies swirling around in here. Now imagine that we start to cool it down. The parts that are saltier and colder, they're going to form ice first. As we keep cooling down, the next saltiest part starts to freeze and so on. This process continues until the whole surface of our ocean freezes and the surface reaches the freezing point. So through this freezing process, the ocean paints its different freezing points right into the ice thickness. Why should we care? Well, this variability could change how the sea ice in the Arctic evolves. For example, it could make it more brittle and affect its future evolution. Right now, the Arctic is quickly shifting towards an open ice regime, where eddies will be able to further impact the sea ice. Thus, understanding them will allow us to predict what will happen in the future.